Hey, everybody, and welcome to week 3 topics. Again, I'm going to do what I did last time, which is just go through some of the problems in the review. Hopefully that helps. If you guys have any feedback for me, please do not hesitate. Number 1, evaluate the expression when P equals 2. I really recommend that everywhere there's a variable, you just put a parentheses. Instead of putting the variable, you put parentheses, and then once you do that, then you fill in the value. When it's positive, it doesn't make as much difference. When it's negative, it makes quite a bit of difference. And I believe we talked about the rule of exponents, where the exponent only acts on what it's next to. The exponent works on what it's next to. What is it next to? It's next to the parentheses. We turn that into parentheses 2 times parentheses 2. I know this is a long way, but understanding makes a lot of difference. And now I really just do things in order of PEMDAS. So I do multiplication first. I have 3 times 2 is 6, 6 times 2 is 12, and I have it times a negative, negative 12. Minus 9 times 2 is 18, minus 7. The rules for addition and subtraction, if the signs are the same, we can just add them all together and we'll make it negative because it's just going further and further to the left on a number line. So let's say here's 0. Let's say here's minus 12. If I subtract 18, I'm still going this way 18 places, which would give me minus 30. And then I'm going the same direction 7 more times, which gives me negative 37. Because whenever I subtract, I go to the left, and when I add, I go to the right. Now we want to learn how to solve for a variable when there's lots of variables. And you can see here that there's no numbers. What we want to do is we want to solve for whatever it says here. It's telling me solve for R, which means I have to isolate R or get R by itself. If I start out with J equals negative M plus R, well, if M was 5, I would have minus 5 plus R. I would add 5 to both sides. But I don't know what M is, but I can always add M to both sides. Then I get J plus M is equal to, well, this is 0, so that's equal to R, and that's our solution, J plus M. I'll do a couple of these because they might be a little confusing. Here, we're solving for Q. I have negative N plus 3x plus Q equals J. And what do I want to isolate? I want to isolate Q. So I'm going to start moving things away from the left-hand side so I can get Q by itself. The first thing I can do is I can add N to both sides. This would cancel the N's, and I would have 3x plus Q equals J plus N. Again, I have 3x plus Q. I don't want that 3x there. I want to solve for Q. I can subtract 3x from both sides. When I do that, this goes to 0. and we get Q equals J plus N minus 3x. That's all there is to it. In this problem, we're being asked to solve for R, and we can see where R is. There's my R. I have to isolate R. I have Q equals R divided by C times A. And I've been saying all along, if you have a denominator and you can eliminate it, that's the best thing to start with, because then you don't have to worry about fractions. What that means to me is I can multiply both sides by C times A. And you can do it one at a time as well. You can multiply by C, cancel the C's. You can go back and multiply by A and cancel the A's. Or you can do it both at the same time. I end up with CAQ is equal to R. And that's my final answer. Important. Capitals need to be capitalized and lowercase need to stay lowercase. If you mix them, you will get it wrong. Just be careful. I want to do this problem because there's more than one way to do it. And I want to show you both ways and let you choose for yourself. First way, first thing I'm going to do is I'm going to find what I want to solve for. I want to solve for B, and B is inside those parentheses. I'm going to start just by recopying it. One way I can do it, I can distribute A equals CB plus 4C. Remember, I'm trying to isolate my B, and always notice where it is. It's right there. Don't worry that there's other letters around it. You just want to first start with getting everything away from the B. Let's subtract 4C from both sides. I end up on the left with A minus 4C equals C times B, and 4C minus 4C is 0. I'm closing in. There's my B. I have something times B. What do? I divide both sides by C. The opposite operation of multiplication is division. My C's cancel. I end up with A minus 4C divided by C is equal to B. And that is one solution. Second way, I can again start out with A equals C times B plus 4. And I could do division first here. You have to know what you're doing. You have to make sure that you don't do anything that's harmful to yourself. And that once you do that, you don't know what to do next. That's why most people choose style 1, because it becomes a lot clearer faster. I just want to show you that also one other way you could do this is I want to isolate the B, which is inside the parentheses. But if I divide both sides by C, the C's cancel. And I end up with A over C is equal to B plus 4. Now we know what to do. We can subtract 4 from both sides. These 4's cancel. I get A over C minus 4 is equal to B. That's another solution. These solutions are equal. Let me show you how they're equal, just in case you're not sure. Let's start with, it doesn't matter. We'll start with number 1. Number 1 says A minus 4C over C equals B. I can separate this into two fractions. For example, if I have 1/3 plus 4/3, I add 1 plus 4, and I keep the denominator the same. Well, I have something similar here, only I'm going from this direction to this direction. If I start out with 1 plus 4 over 3, that's equal to 1 over 3 plus 4 over 3, which is what we're going to be doing. All I did to make this happen is I just flipped both sides of the equal sign. They're exactly the same, except this is the method that we're going to use, which means I'm going to take A over C and subtract 4C over C. And we know that equals B. I can cancel the C's. I start here with N minus Q plus R divided by 6 equals M. And I want to solve for N. And look where N is. It's on the numerator of a fraction with a lot of other pieces. Again, where do we start? We start exactly where we said before. We're going to get rid of the denominator by multiplying both sides by 6. This 6 will cancel with this 6. I end up with N minus Q plus R is equal to 6M. Again, I want to isolate my N, and I'm going to show you something I can do just a little faster. You don't have to go fast. This is for people who are a little bored and want something new. You could just do both of these at the same time. Why can't I add Q and subtract R at the exact same time from both sides? When I do that, this goes to 0 and this goes to 0, and I just eliminated one more step. There's no need to eliminate steps.